SolidWorks Simulation Lecture 9, Linear Buckling of a cantilever beam. The length of the beam is 10 meters, and the Young's modulus 3 times 10 to the 11th, Poisson ratio 0.3, and the result is 3851 Newton. And I'll open a part file and draw a square 50 by 50. Extrude it to 10 meters long. Save the file on desktop. And for the preparation steps, first of all, load the software, and then load the toolbar, and open the study, buckling study. Now, for the third preparation step, arrange toolbar, which is not necessary right now. So I have finished with the first step of analysis, which is drawing of the model and open a study, buckling study. The second step is the material, and I need to copy this steel folder to customize material, which is already pasted here. I can paste here. I can copy the whole folder and paste on the customized material. So I get a steel folder here. And since it is a customized folder, I can change the name of the material into another name. So I can distinguish that this material is the one that I've changed property. And the Young's modulus 3 times to 10 to the 11th, and Poisson ratio is 0.3. So I apply material. This is the material. And for the third step, mesh. Hide the mesh. Step 4. First of all, we fix this end. This end. And then on the other end, I'll place a force on it. And the force is 1 Newton in the normal direction. Right. So I finished with the preprocessors. First of all, step 1, I draw a 3D model and open a buckling study. In the second, I apply material, which I have already changed the properties of Young's modulus and Poisson's ratio. In the third step, I mesh the beam and hide the mesh. For the fourth step, I fix the right end of the beam and place a load on the actual direction with a magnitude of 1 Newton. And then before I calculate, I will change the number of modes to calculate. And actually, you only need one lowest mode to collapse the whole structure. But in order to compare with the values of theoretical model, I will change it into, for example, 8 modes and calculate. And now I get the result, and we can compare the result with the result of theoretical model. So you can see here that first mode is 3856, and the theoretical model is 3851. So it's very close. The second mode 34703, 35795. You can see here that the deviation increases with the mold shape. So for the third mold, this is 96366 and this is 120217. So the difference is increasing dramatically. So we can see here that for higher molds, the difference will be higher. So the answer is very close to theoretical models because it is a lowest mold shape. So here, why is that the theoretical value deviate from the CAE result? Why is that? And which is the correct one? For example, should I choose these numbers or should I choose these numbers? Actually, the correct ones will be the result from CAE analysis because the model is 3D model. And in theoretical model, the beam is simplified into a line. So the cross-sectional effect was ignored. That's why in higher mode, the answer deviates from reality more and more. So you have to bear in mind that in structural mechanics, the beam is simplified into a line. So only lowest mode is very close to CAE result. For higher modes, the theoretical value will get more and more deviate from reality. So this is the buckling analysis.